on what intervals is the function increasing and concave down. The topic increasing, decreasing, and concavity belongs to the application of derivative. Most of the textbook usually spend 1 to 2 long sections to talk about this. If you never studied this before, don't worry about this. Just follow what I do. I will tell you the concepts behind every steps I do. Okay, so first of all, for increasing, decreasing, that is for the slope. So whenever you talk about slope, what are you looking for? You are looking for the first derivative, right? So let's take the first derivative using product rule. So we have f prime of x. So product rule, we use f prime g plus f g prime. So the derivative of x is equals to 1. And then we have e to the negative x. And then plus x, the derivative of e to the negative x is e to the negative x, and then times negative 1. And then this one we have to clean everything up. We have e to the negative x and then minus x e to the negative x, and then we have to set this equals to 0. This is a key step. Why do we set that equals to 0? We are looking for the horizontal asymptote. If you don't know what horizontal asymptote is, don't worry about that. Follow what I am doing, and I will give you one picture to explain everything I do for the first derivative. So let's solve for x. So we have 1 over e to the x minus x over e to the x equals to 0. Common denominator, 1 minus x divided by e to the x equals to 0. And then how do you solve for that? There are two ways to do it. The first way to do or think about it is you have a numerator divided by denominator. What does that mean? Numerator divided by denominator. That means the numerator has to be equal to 0. So therefore, 1 minus x has to be equal to 0, and x is equals to 1. And then this x equals to 1, we call this a critical number, or you can call that a critical value. Another way to think about that is you multiply both sides by e to the x. Okay, so we have one critical number, and then you draw an interval. So when x is equals to 1, the slope is equals to 0. That tells me there is a horizontal tangent line when x is equals to 1. Okay, we have one number. Let's draw a number line. So number line, and then we drop the critical number down. So we have a 1. We have one line, and then we have one cut. Do we agree that we just cut this into two intervals? The first one is from negative infinity to 1. The second one is from 1 to positive infinity. These intervals, they are called test intervals. I am looking for which interval is increasing, which interval is decreasing. To test the intervals, we need a test value. So we pick one value within the interval, pick something easy, pick x equals to 0. You can pick negative 55 or negative 9,000, but when you plug it in, the number you pick, you will have a lot of arithmetic to do. This one, I will pick x equals to 2. And then to test the increasing or decreasing behavior, we have to plug it into the f prime, because f prime is about slope. So f prime of 0, where should we do the plug-in? I suggest you to do the plug-in right here. So you plug in the 0 right over there. So here. So you have 1 divided by e to the 0 minus 0 divided by e to the 0. So we have 1 divided by e to the 0 minus 0 divided by e to the 0. So that is equals to 1, right? Because e to the 0 power is equals to 1. So this is 1. What that equals to is not important. I am not interested. I am more interested in is that a positive or negative. So we have a 1. Slope is equals to 1. This is positive, so greater than 0. Slope f prime is greater than 0. And then how about 2? F prime of 2. You have 1 divided by e squared minus 2 divided by e squared. 1 minus 2. This is negative. So this is f prime negative. F prime is positive. That means the slope is increasing. The function is going up. Slope is positive. The function is decreasing. And then what happened when x equals to 1? When x is equals to 1, we have a horizontal tangent line. So what happened is, let's say we have a parabola. The best way to explain everything I did is using a parabola. So for parabola, the question is saying at the the works, everything we did. So when x is equals to 1, when x is equals to 1, there is a horizontal tangent. So I'm going to write this down, horizontal tangent line. And then when for negative infinity to 1, the function is increasing. 1 to positive infinity is decreasing. So we go up and then we go down. When x is equals to 1, we have a maximum. All right, so we have a maximum. So now we can say that from negative infinity to 1, the function is decreasing. The function is increasing. 1 to positive infinity, the function is decreasing. So that explains increasing and decreasing behavior. So for concavity, concave up or concave down, we have to look at the second derivative. So second derivative, let's do that. So for the second derivative, let's do a f double prime of x. So double prime of x, let's do it based on this. So we bring the negative, we have e to the negative x and then times negative 1, right? Okay, so let's do that. So we have e to the negative x, the derivative of negative x is negative 1. So we have negative e to the negative x. And then we have a minus. This minus is from here. So we have a minus. And then for the product rule, let's put that in parentheses. So the derivative of x is equals to 1, e to the negative x, and then product rule is a plus. And then we have f. So we copy the x. The derivative of e to the negative x is e to the negative x times negative 1. And then we have to clean this up. So what is that equal to? That is equals to negative e to the negative x. And then we subtract e to the negative x. And then we minus, then we get a plus x e to the negative x. And then what do we have? We have negative 2 e to the negative x. And then plus x e to the negative x. And then we set that equals to 0. This is similar to the first derivative. We have to set that equals to 0 to solve for x. And then what x equals to is a critical number. And then again, if you don't know what concavity is, don't worry about this. Follow my work. I will use one picture to show you the concept behind all of this. So you have negative 2 divided by e to the x, and then plus x divided by e to the x equals to 0. See how lucky I am? We have a common denominator. So we have a negative 2 plus x divided by e to the x equals to 0. And then we have to solve for x. So the numerator has to be equal to 0. Plus x has to be equal to 0. So x equals to 2. This is also called a critical number. For concavity, this can be an inflection point, but is that really an inflection point? We have to find out. So let's draw an interval. I mean a number line. So let's draw a number line. So this time we have a 2. We have from negative infinity to 2, and then from 2 to positive infinity. These are called test intervals. So test intervals. And then we pick the test value. I pick a 3, and then this one I pick 0. Pick something easy. So f double prime of 0, what is that equal to? So for the double prime, I suggest you to plug in the double prime to here. Double prime equals to 0. Double prime of 0. So we have negative 2 divided by e to the 0 plus 0 divided by e to the 0. So this is equals to negative 2. So negative 2. So we have f double prime less than 0, and then f double prime of 3. So we have negative 2 divided by e to the third, and then plus 3 divided by e to the third. So this is positive, right? So f double prime is positive. What does that mean? F double prime is negative. That means the function is concave down, like that, just like a parabola facing down. So parabola facing down. Greater than 0 means concave up, parabola facing up. So let me just draw a parabola. Yep, so this is concave down, and then concave up in this interval. So from concave down to concave up, then x equals to 2 is called inflection point. What is inflection point? Inflection point happens where the concavity changes. So let's say we have concave down and then concave up. this is a reflection point. Let's say we have a concave up and then concave down. This is where the concavity changes, and then we call that inflection point. And then at these 2 points, the double prime is equals to 0. All right, so for the first derivative, we have a horizontal tangent. The second derivative, we have an inflection point. And then to answer the questions we have all the way on top, on what interval is the function increasing and concave down, then we have to put 2 intervals, one on top of the other, to find out. So the interval, the big conclusions we have, so let's follow the color code. So this is what we have for the first derivative, right? We have a 1. And then from negative infinity to 1 is increasing, the other one is decreasing. And then what else? For concavity, we have a 2. So let's draw that. So we have a 2, and then we have a concave down, and then concave up. The question is asking what? The question is asking increasing and concave down. So the question is asking increasing and concave down. How do we find out this interval? Increasing and concave down, very easy. Look, right here, increasing and concave down. You have to take care of both intervals, both lines simultaneously. So that will be from negative infinity to past 1. You cannot pass 1, because once you pass 1, the function is decreasing. So the answer is from negative infinity. Let's write this down, from negative infinity to past 1. And then how about this interval? Here, this interval. So that interval is decreasing and concave down, right? Arrow going down, concave down. So from 1 to 2 is decreasing and concave down. So from 1 to 2 is decreasing and concave down. And then how about here? From 2 to positive infinity, that is decreasing and concave up. So that is a decreasing, concave up. That is from 2 to positive infinity. All right, this can be a very good exam problem, so make sure you study that for your exam. If you like it, you think the way I explain math matches your learning, give me a like, share the video for me, click the subscribe button if you are new to the channel. I truly appreciate your help and support. I will see you all in the next one. Signing out.